So hey, how is everyone doing? I need to learn how to talk. Welcome to day 2 of our Intro to Android course. Last time we talked about the basics of Android development, what an IDE is, how to manipulate the user interface, and how to get reactions from the users. We had you guys put together a rainbow app, which would change colors based on each of the buttons you pressed. If you haven't gone through that module, it is available on our YouTube playlist. It's not required for tonight's content, so feel free to stick around with us as we go through module 2, but you should review it as soon as possible, and you will need to complete the project in order to pass the intro course. I hope your projects did go well. We didn't see a lot of you looking for help. We tried to jump on anybody that had any issues. So I hope that means that they did go well. This time, we're going to get down to the very basic and start to build your foundation in the fundamentals of Java. There's a lot of stuff that we did yesterday that I don't feel bad if it went over your head. There are higher level concepts. We wanted to get you something flashy and something exciting running on your phones. This is definitely the opposite of flashy and exciting. I'll be talking a little bit too long tonight, but we'll try and get some participation and get you going on the next project. So Java is a high-level object-oriented programming language. So high level means it's further removed from the hardware is what it's relative to. It's high relative to that. You'll have machine language, which is bytes, and you have byte code, which is slightly above that. And then you have your assembly language, which are super basic commands that translate into the byte code and the machine code. And then you get your next level up are your C languages and things like that. Then you go C++, and almost near the top you have Java. So it has a lot of layers between the actual electrical signals going through the chip and our commands that we're going. So there are things that you give up have it going that high, but you get a lot of advantages as well. It takes care of a lot of things for you, and it runs really well. Object-oriented means that all the code that we write belongs to things called objects. And we'll touch on those today, and we'll cover more in detail next week. But Java was was originally developed and released in 1995 by Sun Microsystems, who was in turn purchased by Oracle in 2010. It's the main language that you use to write Android apps. Although that will likely change in a few years when Kotlin is more widespread. Google's pushing this new programming language called Kotlin really hard. However, there aren't very many jobs right now that require it. So the language that we're primarily going to be working with is Java, and then we'll do a little bit of Kotlin near the end of the main course. So our objectives for today, so upon completion of this module, at the end of tonight, you should be able to create and execute code on Replit, which is an online website that lets you easily write and execute simple programs. You can write text to the screen, both in Android and in pure Java. You'll be able to understand and use comments. You'll also be able to understand and use different primitive data types. You'll be able to understand the difference between primitive data types and reference data types, or objects. And you'll also be able to understand and use assignment and arithmetic operators. And we'll go over each of those, and you'll be able to understand a little bit more. Tonight's project is definitely more basic than the one from last night. I've written an assignment on Replit. You'll have to have a free Replit account to log into it, but it'll allow you to automatically grade and see your results. So you can write your code and test it, and then test it against the code that I have written to make sure it all works correctly. But there are a series of exercises to practice the things we've gone through today, and you'll submit that through Replit. And then as an additional challenge, I'd like you to try and perform similar tasks in Android and then write the output to the user interface. And we'll see how to do that shortly. So our first objective is that our goal is for you to be able to create and execute code on Replit. We'll be using Replit for our pure Java code in this course. It's not the greatest, but it is a tool that allows us to write code, execute it without having to deal with a lot of the superfluous things that are difficult in languages like Java. And it'll allow me to kind of see the code that you're writing, and then you can grade that automatically so you can get quick responses and quick feedback on your code. REPL, REPL, stands for Read, Evaluate, Print Loop. Basically, it's an environment that can execute your code and show you an output. And to use it, you got to navigate to REPL.it in your browser, then select Java from the drop-down menu. This will create a new REPL and allow you to start writing code immediately. And then when you're ready to execute your code, you'll click Run at the top. If you want to save your code across sessions, you could create a free account. And again, that is required to be able to access the assignment. REPL, it doesn't allow us to, it requires an account to access it. So I want you to do that with me. This is really basic, but we can walk through that together. Make sure I'm on the right one. So here we go. See my screen all right? So you go to REPL.it, and you can see here, this is what you're going to see. And if you click the drop down, you can see all of these languages. So all the different languages that REPL supports. So you click whichever one and it'll change. It'll go into that language and you can write code in that language. What we'll do is we'll do Java because that's what we're working on now. You click that and there you go. Here's a new REPL. Here it's prompting you to create an account. But there you go. Now we have this code. All we got to do is click run. So this is the basic hello world code. In programming, and whenever you start working in a new platform or a new language, it's traditional to write an app that simply, like this did right here, prints out hello world. And that's kind of like you saying, I got everything installed, I got it running, it's running correctly. It has a hello world, here I come. And so that's what we do in Java. You notice that's what happened in Android when we created a blank app. It was a hello world app. You can go here and change some of your settings down as well. I like using a light theme, or sorry, a dark theme. It makes it easier to read things and easier on my eyes. But yeah, there's our basic code. And now let's dive in and see what this is, because this is what we're doing today. This is how you write to the screen, and we'll dig into how that happens. So our next objective is that you can write text to the screen, both in Java, pure Java, and in Android, and they are different. So first I want to say, you don't have to understand all of this completely right now. I really want to just plant the seed in your brain, and we'll go in more in depth in each of these things during the intro course. I want you to begin viewing code in its component parts rather than as a whole. You'll see a lot of developers that'll just type out system.out.println, parentheses, hello world, colon, done, semicolon, done. And they don't really think about what's going on. And that's really a limitation. Once you can start digging into the code, if you look at it, you'll be able to understand it much better. Even if you don't understand each of the parts, you'll be able to pick through what you do understand and look at resources online to be able to understand everything else. And it's going to be very, very helpful in everything that you're doing. So let's dig into this. We have the code. I have it marked down with some letters. Let's look at each of these. So first is right here, letter A, your system. This is the system object. The object is provided by the Java virtual machine. And we'll touch on this later today, what an object is and things. But it contains useful tools. One of those tools is the out object. And you notice we access that using the dot operator. So you do system dot, and then it opens up all the publicly available tools that system has. And we want out. And what that is that points to your standard output stream. And of the system, that's going to point to your console. In Android, that actually points to your log window. We'll have that and see that in Android as well. And then again, ought, we'll use the dot operator to access one of the members of out. And there's println. This is a method call. So println is not an object, it's a method. And a method is something that just does something. In this case, println will print whatever we give it here to the console. So to the window that's to the right of your code in Replit. Then we have our parentheses. And that's what we use to execute and call the method, which means we're going to tell the method, hey, run. And whatever's inside of the parenthesis is what we're giving it to run. So in this situation, we're giving it a string, which is just a series of characters or text called hello world. Then we close that paren, and we add a semicolon to say, okay, our statement is done. Go ahead and execute. So looking at these things, we can think of them as pieces of a whole, and that'll help you excel in software engineering. It's a key difference between a software engineer and a developer and a code monkey. Just the different levels of understanding that you have in each of these things. So let's go through. I want you to follow along with me. Let's bring our REPL back up, and we'll delete this because we're just going to type the same thing. So follow along with me. Give you a couple of seconds to get that back up. We're going to type in our first object is the system object. And you can see here, it's prompting us all these things like the IntelliSense and Android Studio, but if I put dot, it's now saying, okay, these are the things inside of the system object that you might want to access. And you can see here, if we go right here, out. This symbol means that they're objects. And we want the out object, which is a print stream. So if I do out and then dot, okay, now let's look at what's inside of the out object. So you see all these things: append, close, notify, all these other things that allow you, that you can use to manipulate the out object. But we want print line. And you put parentheses, put semicolon, and there's our statement. But we haven't given anything to write. What this would do is this will just print a blank line. So if we want to write something out, you do your double quotes, and that denotes a string literal. So it'll interpret whatever text you have in here as a string. And let's go through and we'll say, I'm not creative. So I'll just do hello world again. You can type in whatever it is you want, whatever your heart desires. So we got that. You notice that the text here is orange. If I were to move this and remove both of these, now the text isn't orange, it's white. So this is interpreting this as code. Anything that's white is pure code, and the blues are keywords. And if it's orange, then it's a string literal. This is one benefit you have with an IDE that you don't have if you're using something like Notepad++, you do have that with Notepad++. You don't have it if you're using just plain old Notepad, or in Linux and OS X, it would be like Nano, which is just a very, very basic text editor. An IDE it recognizes what you're doing and will coordinate it, color code it as such. So let's try this. Let's run it again. So we have hello world right there. Let's do another line before we go back. System.out.print line. Do our parentheses. Let's do something else. I've arrived in the Java world. Fix my capitalization. And go ahead and click run. So you can see there, it typed both of these things on separate lines. And then you continue to do that with all the different lines of things you want to write. If you do, and in this, if you just type a bunch of garbage, you see it wraps here. If I print that, it's not quite long enough. But if I make it long enough and I print it, it'll automatically wrap around as well. But they're considered still a single line. So let's go back to our code and let's play around and do this in Android. First, we'll step through and walk through how it's done in Android. So in Android, it's very similar. You can use system.out.println, but instead of displaying it on the user interface, it'll display it in your log window. That's because Android has a built-in GUI, a graphical user interface, instead of the console, and we interact with it differently. Just like we did yesterday, we'll need to do the following steps. We need to, first, we'll add an ID to our XML code. Then we'll have to declare the data member, which is our handle. After that, we will assign the value of our, so we have a semicolon here. We're going to assign the value of our data member, of our text view object. We're going to use the assignment operator to assign it the value of. We're finding our view, our component, by its ID, our ID, and the ID is text view. So now we have that. Now any manipulation we do to this text view object will be reflected in the screen. So let's do that. Let's use text view. And then we're going to use the method call. We're going to call the set text method. We use that to manipulate the text on the screen. We're going to set the text, the value of, this is the new text value. And then we have that in double quotes and the parenthesis and do the semicolon. And that's it. And that will update a string in the user interface. So let's do that. Go ahead and create a new project. I have one right here. I wanted to play around with it a little bit. This is a, let's see if that's good. This one is, you can see it's different from the project we dealt with yesterday. This is the, when you go through and select your project, I selected the basic activity to kind of just show you the difference in the different code. You can select empty activity, select whatever you want. I'd recommend just doing empty activity or basic activity so you can see this here. We'll be able to see what one of the other templates does, which is kind of cool. But you can see how it auto-populates a lot of this code for us. You got the create options menu. You have a few of these other things. It has a menu. It just has a lot of good stuff for us to get going, get up and going quicker. So let's go into the same thing. It doesn't matter if it has this code or any other code. We're going to add an ID to our text view. So hopefully you guys all got your project going while I was rambling. So we're going to give an ID, doing ID, and we're just going to do text demo. And there we go. We finished up our ID. So now we go back here and up at the very top, right underneath our class. So we're adding it as a member of this class. We're going to say text view, and that's going to be text demo. Then we're going to come back down here and we're going to say text demo. We're going to assign it the value of. We're going to find that value, finding view by ID. And then we'll do r dot ID, ID dot text demo. You can see there that even though I might not have remembered everything, because we used this predictable naming scheme, it tells us, hey, look, here's an ID. This is what I think it is. And yep, that's it. Go to the end, do our semicolon. So there we go. We have our handle. We attached it to our drawer. And now we're going to use the dot operator this time to access the text parameter. But you can see here, let's go back. I finished text demo dot. We can scroll down and see all the different things that you can set. So I'd encourage you to kind of play around with some of these things. One, you'll be able to see typeface. You'll have to do some research into that. That one's a little bit more complicated. Append. So all these different things that you can play around with, and I really recommend doing that. As developers, there's no way, not in a 6-month course, not in a 4 years course, not in a PhD course, there is no way for you to be able to learn everything there is to know. Because it's always changing, especially with Android. Every year there's a new version of Android. Every year something new is added. I had one of the PMs point out to me earlier how you can see here the constraint layout. That is new. That was added recently in the last year or so, and just this year they just started defaulting to that. It used to default to right here when you create a new project to a linear layout, which is much easier for beginners to work with. But for some reason they wanted to change that to a constraint layout because they're really pushing it. It's a powerful tool, but it's not conducive to beginners. And that's just something they changed recently. So you'll never be able to get everything. So being able to sit down and look at documentation and dig through it and learn new things and experiment with them is going to be how you're going to learn. And we'll be doing that throughout this course, looking at different types of documentation and see how that runs. So anyway, back to the task at hand. Follow along with me. Make sure we have your your handle, you attached it to the drawer, and then we're going to use the dot operator to set text. And we're just going to say, this is output in Android. I'm bad enough at typing, but this huge microphone in my face, it makes it even harder. So now let's bring up our testing environment. Move that out of the way so we can run the code. Excuse me. Now it's running. It's installing. Let's get that going. There you go. So you can see instead of hello world, this is now saying this is output in Android. And you can see a few differences here. You have this drop down here that we didn't have before, and you have this button here that does some different things as well. And these are, this is what you get with the basic activity. So you do get this button and you do get this drop down menu here. And so you can, and again, I encourage you to play around with these and see some of these other ones. It's really great, and you can be able to learn how it runs. But there you go. That is text output in Android. But before we go, let's show you how what happens if you do the print line. So let's try system.out. And you see it's prompting us again, like in Replit. Print line. This is the system output stream in Android. So let's go ahead and we'll execute that with our instant run. Let's bring up our window here. So it's executing that, it's good to go, and let's bring up our log. Let's see what happens there. Let's change that to this. There you go. You can see right here, system.out. So that was the tag of the log. So it sends it to the input stream, the info stream, and then system.out. And then that's our system output. So if you use system.out, it'll output to here, just like yesterday when we used the log.i, it'll output to here. So you can see Android's still Java. It's just has all of this built on top of it. So let's go back and let's move on to the next part. I have a challenge for you guys to work on over the next few minutes. So what I want you to do is I want you to go back into Replit, and I want you to write a short bio about yourself. So be sure to create new lines where necessary. And here's the example. Follow a similar format. It doesn't have to be exactly the same. And a tip here is that each of these lines, notice where they end kind of short. These are all new print statements. So here's your print line, here's your print line, here's your print line, and then this is one big print line because it wraps around. You're not going to 100% be able to eyeball it, but it makes sense that these would all be separate lines, and this is going to be a big chunk. So spend the next, let's give you 5 minutes to play around with that in Replit, and then we'll jump back in and continue with the next objective. So I think I misspoke. Let's give it just a few more seconds. Um, this is just for an exercise for you to work on. I don't want to keep people waiting that were quicker to do it. And I just typed it up and it was much faster. And yeah, I see some of your comments over there. Yeah, math class, that's what I did. I wrote a game where you were a W flying through the screen, flying across the screen, and you would shoot some other letter. You'd shoot it and they'd blow up, and it was great. But here's what I put together. Yours is probably going to look similar, but not the same. You can see here too, right here, this is really helpful. These are line numbers. So whenever you run into issues with your code, like if I were to delete this and try and run the code, it's going to be a bunch of errors, but it's going to say 6. So it's main.java. So our file's main.java, and you have 6 here. So it's saying line 6. And since this is longer than a single line, it wrapped around. Where you can just get rid of that, and then you can run it. So thanks for participating in that. Let's go on and move on to the next one. We're going to work with comments. So upon successful completion of this objective, you'll be able to understand and use comments. Comments are tools that allow developers to add information about what their code does and why. The comment here is very apt. You'll be surprised how many times you run into situations like this. Friday evening, you're ready to go, and come back Monday. Say, what does it mean? And it doesn't even have to be that. It could be Monday to Tuesday. It could be, I'll finish this after lunch. And you get back and say, what in the world was I doing? It's not that it was bad code, or it was just your mind encompasses all of these things, and you step away and you say, and it just gives it up. So comments are not only useful to other developers, but they're going to be really useful to you. And there's no such thing as too many comments. Always err on the side of a lot of comments. Be sure to explain your code so that other developers on your team will be able to understand what's going on. There are also times when you run into issues and you have to build your code in some weird way. Comments will explain this to other developers to come along, and may also lead to developers helping debug your code as well if they've run into similar issues. You'll hear a phrase a lot called self-documenting code, and this can be a very bad phrase. Code that's easy to understand is always fantastic. You should strive your code to be very easy for others to understand, even if it means not necessarily the most efficient way of doing things. As long as it isn't noticeable to the end user, just having cleaner code and easy to understand code will be very helpful. However, you don't want to use this as an excuse to not add comments and explain your code so others can come back to it, which many people will do. They'll say, oh, it's self-documenting. I mean, I don't have to document it. No, you should still document it. Comments can also be used to temporarily disable blocks of code. This is useful in isolating bugs and testing out new ways of doing things. And there are 3 types of comments. You have your line comments right here. If you start a line with a double slash, in fact, anywhere on a line with a double slash, everything after that will be a comment, so it won't be executed. You have a comment block, and this can span multiple lines with a slash star and then your content, and then your star slash to end it. Just remember whatever touches the stars is a comment. Whatever touches the slashes is a code in this situation. This is also why I love keyboards with numpads. I can't do the smaller keyboards just because I'm so used to using the slash star on the end of the keyboard. And then finally, you have java.comments. These are pretty unique to Java. They're specially formatted comments that can be used by tools to generate documentation. These are placed before methods and classes, and also at the top of files. And we'll be able to see that when we play around with it. They provide standardized tags using the @ symbol to define different characteristics of a method or class, and are generally the best way to clearly document what each of these things do even if you don't use them to generate documentation. So let's play around with that. Let's go to REPL first, the one we're just working with. So here we go. So let's add a comment here. I am writing outputting a bio to the screen. And so you will run this, and you'll see the output's the same. It didn't execute this as code, and you'll also see that there's green. Green is another way that it color codes the system to tell us, hey, this isn't code, I'm not going to execute it. So let's do something a little bit more. Typically at the top of files in code, you'll run into a copyright. And this is what developers use to show you what you can and can't do with their code. So what you can do is you say copyright, let's see, C 2018 and your name or your company's name. A lot of times when you have with your company, they'll have standard copyright language that you should include in all of your code in every single file. That helps them protect themselves. So type that, and then let's do something else. Let's describe what this class does. So this is a class to demonstrate the comments for Lambda Intro to Android Module 2. You see here we have 2 lines, and they're 2 separate comments, and that's fine. Typically 1 to 2 lines are fine to use single line comments. It's when you get to 3 or 4 that you want to convert that into a multi-line comment, a comment block. So let's delete these and do a multi-line comment. Remember, follow along with me. You notice they're all white and blue now, so it's not a comment. But if I do this, it's now a comment, but everything's a comment. It's saying, hey, where's my code? There's nothing. There's nothing. I wanted an end, but I can't find an end. What it's doing is since we don't have an end here, it thinks that everything is a comment. So then we go ahead and we'll end here. We'll put our end, and then it's fine. Now this is all green, and now you have your comments. But like I said, typically at the beginning of files, you want a Java doc comment. And this is clear. This is a standard way to document things, and it provides a lot of tools to be able to make it very clear to developers what you're doing. So the way you do that is you do your / ***, and then every subsequent line is a star space to end it. So let's add a couple more lines. And we'll have a blank line there, and we'll start using our tags. So one of the comment ones, here you go, it's prompting us an author tag. So author, and you put your name. Whoops. For some reason, it thought I wanted to write that. No, that is not what I was typing. If I can learn to type my name, it'd probably be better too. Star space. And let's use another very common one, a version tag. This is something you want to get ingrained in you early on. Versioning your code will be very, very helpful. It helps you determine like what version of code your customer's running, if they run into bugs or other developers. Every time the rule of thumb we always used at the last place I was at was every time you send code to someone else, you increment the version. So 1.0, 1.1, 1.12, 1.125, whatever it is. And then when you send it to a customer, then you do 0.0, or when you go through a release process. And that's something each place you work at is differently. They'll walk you through and work through your release process. We're 1.0, and we'll just do today's date. And that way we know that this is version 1 of our code. It was last updated on this day, So we can send this code to someone else, to your PM, to other people you're working with, to colleagues, and they'll know that it's version 1. And then the next time you go through, you can have version 1.1, 1.2, whatever you want to do. So here it is. This is our single line comment, and this is our JavaDoc comment. Nothing you want to do. You want to make sure nothing is on the first line of the JavaDoc comment. That way your comments are all lined up and they look nice and look clean. Clean code is going to be very helpful. It's part of that self-documenting. Let's go into Android. We'll look at some of the tools that Android gives us. I'll give you an example of some code that I'm working on. Let's do the toast. So this is the project that I was talking about yesterday. It's an app that lets me control the RGB LED light strip that I have set up in my kids' room. But what we'll do is first we will do a single line comment. So I control or command slash, that comments out that line. And if I do it again, it uncomments it. And that's really helpful to quickly uncomment and comment lines. You highlight a block, control shift slash will do a block comment. Control shift slash again will uncomment that. And you notice you can do that from anywhere inside of the comment. Let's undo that. Actually, it doesn't matter. Let's highlight this again. If I don't use the slash, it'll all do single line comments. So those are some good tools that you have. Another thing, let's do a JavaDoc comment, see what Android does for us there. Slash star star, enter, and there you go. See, it added as a param text. So I can just say, this method will display a toast to the user. Toast of short length. And then here we have our text parameter, and I can just say this parameter is going to be the string that will be displayed to the user. You guys have you ever used your phone? You've probably seen this before on an Android device if you're an Android user. When you're doing something and at the bottom of the screen you'll see this like black bar kind of appear with some text inside of it, and it'll flash up for a few seconds and then disappear. That's called a toast. And that's more of just like a notifying the user, hey, this is something happened. I don't want to interrupt you, so here you go. It's usually, let's see, what's something I ran into today. If you set the wallpaper, it'll toast up and say wallpaper set, possibly. And just a lot of things. You'll probably have seen it. If not, we will be working with these. They're a very, very common way and a very useful way to display things to user. But anyway, those are all that's how you do all of our comments. And you can do that in your projects and things like that. That can be really helpful to communicate to other developers what's going on. So let's go back to here and we'll move on to the next part. The next part, we're going to talk about data types. So this next objective is that you will be able to understand and use different primitive data types. So these are, so you remember when we created our handle, we had to declare that it was a type button. That's called a data type. So you type button and then the name, it's going to create a data type with that name of type button. Java gives us 8 primitive data types. Primitive data types means they are not objects, and we'll talk about the difference between the two in the next slide. But you can see all these different types, and they all vary in the amount of size that they have, the size they take up in RAM, in memory, the values, that the range of values they can store, whether or not they can store fractions, and then what the default value is. So we'll step through this. A byte can surprisingly hold 1 byte. And that byte can store anywhere between -128 and +127. A short is 2 bytes and can hold up to 32,000. An int can hold up to 2 billion. And a long can hold up to this many. Pentillion, possibly. None of these can hold fractions. They have to be whole numbers, whole integer values. You can notice too that if you put an L, a capital L at the end of a number, it will automatically translate that into a long. But you see a long will take up 8 bytes, where a byte or an int will only take up 1 or 4 bytes. So that's one thing you have to decide when you're determining what type to set the value. It how much storage you want to take, and then also the range. So when you declare a value, it will tell what it does is it tells the system to reserve the set amount of memory, so whatever is in this column here, and then it tells the system how to interpret it. So you notice that both an int and a float are 4 bytes. However, a float can hold different values than an int, and a float can hold decimal values, and that's distinguished by a lowercase f. So by doing this, we tell the system, hey, I want 4 bytes, but I want them to be floats, which are decimal values. Have you ever noticed in software you're using that sometimes you just can't put a decimal value? It forces you to use a whole number. That's because they're storing it as an int, as an integer or a byte or short or long. One of these, they're storing it as. Whereas if they store it as a float or a double, they can store those more precise numbers. And you can see 6 to 7 significant decimal digits, and then 15 decimal digits, and then the F and the D. Now we get down into a character, and you notice a short and a character take the same amount of memory as well. But a character is 0 to 65,000 because it's Unicode. You can follow this link here and kind of see what Unicode is. You look that up. It's a way of storing images and text, or I should say characters. So each of the characters you type, whether it be this U or this N, these are all different Unicode values, and they're stored in a char. And a string is a series of char values. You can see that's denoted here. If you use a single quote, you can either put the Unicode code, or you can put a character like the D or the F, and that'll store it as a char. And finally, one of the most important data types is a Boolean value. Boolean can hold true or false, and that's what's going to control the logic of all of your programs, are these true or false values. And we'll do a lot with those in the next couple of days, playing around with those. So let's move on. We will look at that. Let's go back into Replit and work on this with me. Just do this one. Let's delete all of this. And we're going to create a value. So we're going to create a byte, and we'll call that number. This isn't the best name, but since we'll play around with it. Oh, whoops, you don't do an equals there. Scratch that. Byte number equals, and we assign it a value. You don't have to assign it a value here. You can delete that and then come back down here. Number, just like we were assigning a value to our buttons. We're assigning a value here of 15, and then semicolon. That's good. Oh, you need to get rid of that slash too. So now let's do this. Let's take our print, go back to our print stuff, system.out.println, and we're going to print out our number. Semicolon at the end, and let's run it. So there you go. We see that we've printed out the value of 15, whatever is in the number. If we were to come down here and change the value, number is now equal to 12, it'll print out 12. And use the same thing with everything else. Let's do a little bit with characters and Booleans. Byte, short, or let's do, we'll do characters and Booleans for a little bit, and then we'll touch on some of the other ones in just a minute. So we do char. It's just awful to name it char. So we'll character, you can name it whatever you want as long as you put it here. And then we're going to assign it the value of X. We use so single quote, X, and then a single quote, and there's a character. Notice if you use a double quote, that would work as well, because what it does is it converts it from a string to a character. But for clarity's sake, you use a single quote for characters, double quotes for strings, which are series of characters. And if I run that, there we go. You have your X. So now let's change that to, I'm going to use Boolean and see how that works. So Boolean, Oh no, that's a keyword as well. Just call it test. Semicolon. Put that there. Now we're going to do test equals, and the way you distinguish true and false is different in many programming languages. In Java, if you type it's all lowercase, that's false. Some programming languages are like this with the single capital, the first line or first letter capitalized, or all of them capitalized. And the way you can tell which one to use is you have your IntelliSense over here saying, oh, it needs to be lowercase, but it also changed color. So you see that was blue, that's white. That's something that an IDE provides for you versus something like Notepad that doesn't do that for you. But let's go ahead and print it. Oh, sorry. And that's another thing with different languages. You have bool versus boolean. Some languages will use bool, some languages will use boolean. Let's do that again. And if you saw over here, it told us there was an error in line 3, and I can see line 3, there's an error. So there we go. I set it to the value of false, and it printed false. Notice this false is not a string. We don't set it to the string value of false. False is a keyword that Java recognizes, and will translate it into the byte representation of a false, which is usually 0. I haven't tried this in Replit. Let's see what happens there. So that's going to be an error. See, what it's trying to do is it's trying to convert an int to a Boolean, and it can't do that on its own. We have to do different things, and we'll play around with those later on. So now let's go back, and we're going to see what an object is. Just got a bit more time on there. So we're going to understand the difference between primitive data types and reference data types. A reference data type is also known as an object. And they are a combination of primitive data types and functionality. So they have multiple members. You remember when we were typing the system dot, and you use the dot operator, you saw IntelliSense prompting you all these different things. Those are different members of that object. So they had objects, they could have primitive data types, and they could have methods. And these are all different things that can be encapsulated in an object. So an object can store data, and it also has a state, and it has methods, which is functionality. So we've already used some objects, like the buttons. The button that we use, the text view, those are all objects because they have all of these things. They're like the drawer that we were talking about. There are also object versions of all the primitive data types. And those are distinguished by using a capital letter, and then with an integer, you use capital integer rather than just int. And they add related functionality and constant values. So let's dig into that. Let's go back to our REPL. And we're going to delete these two. I'll keep the test there so we don't have to type that again. That imported, that's not what I wanted. So let's do a long. So you notice that's capital. So it's saying it's going to be a long, which is going to be test. And then we're going to assign it the value of, if we go into the long object again with our dot operator this time, you can see all these different things. You can get long, you can do all these different things, and those are located in the documentation. You can give it 2, and it'll tell you which one's bigger. So a lot of things that seem really basic, but are really helpful. You can add them together, but you also have here these blue. These are data members. So other variables, so that's an int. You can see the type here is that it's an int. That's an int. But what we want to do, let's play with this. Long.size. So this is going to tell us in this long object, it is storing the value that is the size of a long. So if I run that, Replit doesn't like me. If you run into this issue, we'll copy it. Let's just try refreshing. Change it to dark theme because that's burning my eyes. So let's try this again. So if you do run into issues with Replit, just go Control-A, copy your code. There we go. You copy your code and you can paste it. You refresh it and then paste it. This error is telling us in line 3, we have incompatible types again. An int cannot be converted to a long, so it's not letting us convert that. So what we can do, we can just change this to an int. And we'll run that again. It's kind of interesting that a long is going to store a value, an int value as its size, but that's code for you. There you go. So this is saying it's going to be 64 bits. Yes, 64 bits. Which is 8 bytes, because each byte is 8 bits. So let's go back and make this a long again. And let's see, what's the biggest thing we can store in long? So we'll type it again so we can see our, it doesn't like using our IntelliSense, but what we do is max underscore value. Replic's not behaving very well right now. There we go, we'll run it again. We'll give it a minute or 2 or 3. Come on, buddy, you can do it. There we go. So that big number right there is the same number we had in our sheet, showing us that a long could store a value up to 9 pentillion, if that's a real name. So let's do some stuff with some other types. Let's look at float. We haven't done anything with float. So we'll use the float object this time so we can play with that. Actually, you know what? Let's just do the lowercase. Let's just do the primitive data type. Float test equals float. Oh, there's our IntelliSense again. So that's lowercase. You can see there's nothing. The dot operator is not going to do anything. But if we do the uppercase, that gets us our object. All of a sudden, we have all these different options. Some of the things that I've never even played around with. But if you look at your minimum value and we run that, look at that. Replic's hating me again. So let me just copy that. I'm going to close this and we'll go back into the other REPL. And we'll just go here. I have this one that I had prepped and ready to go just in case something like this happened. There we go. 1.4 times 10 to the negative 45. It's the minimum value that can be stored in a float. So let's go back to make sure we've touched on all those things. Yep, we got the character, we got the Boolean. So let's move on. Let's do something with these data. I know it's been really boring, it's really long, but we're actually going to do something now, and you're about to see a huge wall of text. So this next objective is that we'll be able to understand and use arithmetic operators. And you can see, whoops, these are all just like you have in math. You have your assignment operator. Remember, this is not equals. This is the assignment operator. It stores the value to the right at the memory location indicated by the data member on the left. So basically, if I say what we were doing, float test is assigned the value of 5 or whatever we put. Multiplication, you notice this is a star and not an X or a dot or anything like that. So multiply operands together. You have your division, your addition, subtraction. These all work like they do in standard arithmetic. They even follow the same precedence rules. Do you guys remember, as I go through this, what is the phrase or the word that is the precedence for arithmetic operators? See if you remember that as I go through. Next, you have the modulo operator. And this is new. I hadn't seen this before in anything. And I got pretty far in math. It returns the remainder of a division operation. So for example, if I do 12 modulo 5 or 16, let's do 16 modulo 5, it doesn't return 3 or 3.2. What it does return is it returns 1. Because 16 divided by 5 is 15, or is 3 with a remainder of 1. So it tosses the 3 and gives you a remainder. This is really helpful when you're trying to determine if something is even. If something's even, you do modulo 2. And if it's 0, it's even. If it's 1, it's odd. If you want to see if something's divisible by something, so if you want to see if 108 is divisible by 9, you do 108 modulo 9. And the value that it gives you is going to be 0 if it's divisible by 9. Next, you have your unary operators, your increment and decrement operators. Unary means it's two symbols that are treated as one symbol. So if you put plus plus before or after a variable, it will increment the value and store it in that variable. So it's like you would say int test or int number equals number plus 1, but that's all done right here. Post and pre, you see increments after the statement executes and before the statement executes. And we'll play with this and we'll see what it does. And then decrement's the same thing, but it just decreases the value instead of increases the value. So let's go back into REPL. Oh, right here. Let's open that up. Now let's work with our operators. So we're going to go back to an int equals, we'll just do that. And then we'll go test equals 5 plus 6. Make that easy there. So it's just like in math. Let me see if I can zoom this in. I can, but it's kind of weird. If I run that, what it's doing is we're reserving memory. We're reserving 4 bytes of memory in the system and storing that and naming that location test. Then we're taking 5 and 6, we're adding those two together, and we're storing the result inside of at the memory location here. Then when we come here, we say, I want to print whatever it is that is at that memory location. So that's simple. And you see if we do multiplication, we're running the same thing. If I run that, we're now multiplying these together and we'll get 30. Division works the same. And then remember you have your precedence is PEMDAS, or please excuse my dear Aunt Sarah. You have anything that's inside of parentheses. You have exponents, and those go. And then you have your multiplication and division. And then you have your addition and subtraction. And programming recognizes all of those or respects that order of operations. Your unary, increment, and decrement operators depend on how you store things. So let's do this. We have 30. Let's increment that and run it. Wait, that's at 30 again. But I said that it increments it. Well, actually what happens is since we put it after the variable, we're saying we want you to execute this statement and then increment it. So if I were to come down here and do system.out.println test, and we run that, so what it's doing is we're reserving memory, then we're multiplying these values together and storing that in test, then we're printing whatever's stored here. After we print it, we're incrementing it by 1, and then we're going to print it again. And look, we get 30, then 31. If I were to do this here before, let's try that. You'll see here that it multiplies 5 times 6, which is 30. Then it increments it, then it prints it, and then it prints it again. So we get 31, 31. Now I want you to play around. We'll play around with one more thing. I know we're running a little bit late. One of your assignments will be kind of puzzly. And I want to be able to show you what that does. Like we said, increment and decrement operators will do things before and after the statement executes. One thing that we'll do as well is we'll take byte and we're going to assign it the value of byte.maxValue. And then we're going to print it. Let's see, we're going to print it and then we will increment it and see what happens. So we're sending it the maximum value that it can hold, but then we're going to add 1 to it. So what's that going to do? See, the maximum value it can hold is 127. If we increment it, instead of going to 128, it can't store that. So what it does is it goes to negative 128, which is its minimum value. And you notice too, if I were to do this, we'll copy this, we'll paste it, and then add 2 at the end. We'll run into something different as well. You see, we have 127, 127 again, and then negative 127. It looped around, but it skipped negative 128. It's because this is what we did. We stored it, we printed it, then we incremented it, then we incremented it again, and then we printed it again. And that it works the same way if you decrement it. Except when you're decrementing it, it's not going to wrap around. It'll store the maximum value, print the maximum value again, and then it'll go down by 2. So one of your assignments will be to play around with that and try and match an output. So now let's go into, let's go back to the assignment. Almost done. It's just going to be a couple more minutes, and then I will let you loose. Nope, that's not the assignment. That's the assignment. So remember, the task is going to be to complete the Intro to Java assignment on Replit. I'll be pasting in as soon as we're done here. I will give you a link to our classroom on REPL. It is where we'll store all the assignments, and you'll be able to access the assignment and test it and run it and all that stuff. You'll submit it through Replit. I'll show you how to do that. And then as a challenge, I want you to practice performing similar tasks in Android and then writing the output to the user interface. The tasks will be the same and the same to do, but outputting the interface, one tool you'll want to use is append, and that will just add something to the end rather than writing over it. Rather than set text, you append to the end. So let's jump into Replit. We'll see here that link will link to our GitHub repo. These are your instructions. You create the account and join the classroom here. And then you go ahead and you follow the instructions, type the code where it tells you, and then you submit it. So let's open that up. Let me reset this view. It makes it a little bit easier to see. So here, this is the view that you'll see. You see here, all this right here, this is to allow the automated grader to work. What it does, so you know, it pulls input from the user, and that input is set right here. So if you want to test your code, just type 5, 6, and then it'll test your code having X be 5 and Y be 6. They get those values. And then you just set input, and then when you run it, it'll run it with those values. So you don't need to worry about this. Your project starts right here on line 24. So you'll see here, there's an exercise as a comment. It'll tell you what to do. So you declare a data member, assign it the value of Z, and print it to the screen. And you'll do all that and see you have Z here. So you just say, you assign it that value of Z. You can assign variables to other variables, and it's great. You see exercise 2, and each of the parts of this exercise are done here. So you write your code under here between these braces. And same thing, between these braces. Here's the one that I was telling you that was kind of puzzly. What I want you to do here is you'll start with 126, and I want you to play with the increment and decrement operators, and I want you to try and match this output. And it'll be a bit of a challenge, but it's a fun challenge to be able to figure that out and see how that goes. That's one of the errors that you'll run into with your code. Sometimes you use the post increment or the pre increment, and it'll not do exactly what you need to do. Or sometimes people are just being difficult, and they'll just do all of that post increment, pre increment, all that stuff to manipulate values rather than just writing the values. In fact, a few of my assignments and tests when I was in college were, what happens if I post increment? What happens if I pre increment? What's going to happen here? And they just go through all big chains of them. And this one's easier. You'll output it each line. So you just do system.out.println and post increment, pre increment, whatever you want to do. And then finally, your exercise 4, you're just going to do whatever it says here. Add X and Y together and print the result. And you can do all of that. And then when you're ready to go, you can click Run Tests, or you can just run your code to test your code. Make sure you have an input here. Otherwise, it'll hang and kind of be weird. And then when you're ready to complete your test, you click Submit, and it'll run through the pre-written tests that I've done. This code is empty, so it's going to fail, but it will tell you It'll tell you whether or not it passed or failed. But there you go. There's your assignment. It's not as flashy or as fun as yesterday's, but it's going to be very helpful for you to learn these principles and then ingrain them when we prepare for the next one, which will be going deeper into conditionals and Boolean values and things like that. But thank you again for participating. Thanks for everything. I know it was a very long monologue, pretty boring, but I appreciate you sticking with it till the end. Feel free, I'll be here. Your PMs will be here. Message us for questions or issues that you run into. And I look forward to working with you tomorrow. See you later.